Okay. Hi, please welcome to my YouTube channel. Today, before this video ends, I just hope you will learn how to do differentiation without using chain rule. Then another rule known as product rule. You know, at times you need to find your differential within a short time, like an objectives. So if you know how to do differentiation without using chain rule, it at times helps you to find it within a short period of time. Then that will help you to do other differentials. It will help you to do other differentials like product rule, so that the question will not be bulky. I mean, the solution to a particular question or problem will not be bulky. Okay, come with me. So if there is a question like this, you know, chain rule states that let u to be equal to the base of the equation of the curve. So if you don't want u to be equal to the base and you want to find a differential directly, that's differentiation without using chain rule. It simply means that to find your dy by dx, drop the power 4. Now you differentiate the base. If you differentiate the base, when we differentiate this, we get 10x. The differential of this is 0. Then you repeat the base again. And now you reduce the exponent by 1. So you drop the power. Then you differentiate the base. When you differentiate 5x squared, you get 10x. Then you repeat the base and reduce the exponent by 1. That's how we do differentiation without using chain rule. Then you polish this. 4 times 10x, you get 40x. Then 5x squared plus 3 exponent. Then this becomes a gradient function of this curve. Okay, so there is another question on the board, and I want to do differentiation without using chain rule. Differentiation without using chain rule. So it just means that drop the power, alright? Now you differentiate the base individually. So when you differentiate this, you get 8s. You differentiate this, you get 3. Then you repeat the base. So 4s squared plus 3s plus 2. Then you reduce the exponent by 1. So that becomes 2. Then you can polish this. 3 is constant. It can multiply what is in this bracket. 3 times 8x, that will be equal to 24x. Then 3 times 3 is 9. Then you have 4x squared plus 3x plus 2 exponent 2. You can expand this and use it to multiply. However, this becomes a gradient function of this curve. Okay. So, as I told you, we'll be talking about product rule. We'll be discussing product rule. Another rule very important in differentiation. So, if a function is in this form, that's y equal to u, where u is a function and v is another function multiplying each other, then the ideal method to use is product rule. Product rule. And product rule is saying that if such things happen, your dy over maybe ds, the independent variable, it will become v du over dx plus u dv over dx. That's the v multiplied by the derivative, the differential of u in respect to the independent variable x, plus u multiplied by the differential of v in respect to the independent variable x. Okay, so questions in this form requires the use of product rule. There is no need expanding the two before you differentiate. So as I introduce you to it, you let u to be equal to the first one and v to be equal to the second one. That's y equal to uv, y equal to uv. So this is in that form. So we let u to be equal to the first one and v to be equal to the second one. So let u to be equal to 3x squared plus 5 and v to be equal to 4x plus x squared. Now you differentiate u with respect to x and v with respect to x. So our du over dx will be equal to 6x and our dv over dx, you remember the differential of a linear thing is a coefficient of the constant. Then the differential of this, that will be 2x. Now product rule is saying that this multiply this plus this multiply that. Thus dy over dx will be equal to v times du over dx plus u times dv over dx. So what's our v in this case? Our v is 4x plus x squared. So 4x plus x squared times what's our du over dx? That's 6x plus what's our u? Our u is 3x squared plus 5. And what's our dv over dx? That's 4 plus 2x. What do we do now? We multiply, we expand the two brackets. We expand the two brackets. 6x times 4x, that will give you 24x squared. 6x squared times x squared times 6x, that will be equal to 6x cubed plus 4 times 3x squared, that will be 12x squared. 4 times 5, that will be 20 plus 2x times 3x squared, that will be 6x cubed plus 5 times 2x, that will be 10x. Now what do? We rearrange them in order of their magnitude. So in order of their magnitude, so we have 6x, okay, plus another 6x cubed. Then we have 24x squared plus 12x squared. Then we have 10x plus our 20. So what do? We add 6x squared plus 6x squared, that will be 12. 6x cubed plus 6x cubed, that will be 12x cubed plus 24 plus 12, that will be 36x squared plus 10x plus 20. Then this becomes our gradient function of this curve, of that curve. I hope you understand. Please go over the video, try to check the expansion very well, and I know you'll get it. Okay, there is another question on the board. Y is equal to root of x multiplied by x squared plus 1. So there is no need expanding. Even to expand this, you face problem in expanding. So to find the derivative of this curve, we just let u to be equal to the first, then let v to be equal to the second. Then differentiate each of them. You know, x, the square root of x is the same as s exponent half, so we change it to that. So to differentiate this, our du over dx will drop, so we'll drop the half. Then we subtract 1 from half. Half minus 1 will be minus half. Then our dv over dx will be equal to 2x. Now we can polish this using this du over dx. That will be equal to, you know, anytime a number is being exponented by a negative, you can rewrite it in an indices form. There is one video on indices. You check it out. So this can be written as 1 over 2 s exponent half. Then our dv over dx is still that. That's 2x. So what is the product rule saying? Product rule is saying that you let this multiply this times this multiply that. So our dy over dx will be equal to v du over dx plus u dv over dx. So what's our v? Our v is x squared plus 1. What's our du over dx? That's 1 over 2s exponent half plus what's our u? Our u is root of x. Then what's our dv over dx? That's 2x. So we can polish this. You know, s exponent half is the square root of x. So we can rewrite as x squared plus 1 over 2 root x plus root x times 2x. We can still polish this. Let me wrap a part of our board so that we continue from there. So remember our last step was this. Yes. And this will be the denominator is 1. So we find the LCM of this. The LCM is 2 root of x. 2 root of x. So with this, divide that, it will be 1. 1 times this will be x squared plus 1. Then if this divide this, the answer will be 2 root x. So 2 root x, 2 root x times 2x root x. So what do we have? We have x squared plus 1. See, root x times root x. Instead, when you have root x multiplying root x, that will be root x all squared and the answer will be x. So root x times this root x is x. So we can have 2 times 2x, that will be 4x. Then root x times root x is x. All over 2 root x. Yeah. Let's check it out and see if we are correct. So let's check it out and see if we are correct. Now the LCM is 2 root x. So if 2 root x goes here, it will be 2 root x, not 2x root x. So let's correct that. Let's correct that. So we can have x squared plus 1 plus 2 times 2. Okay, 2x is here. 2x times 2. That will be 4x. Then root x times root x, that will be x. All over 2 root x. I hope I've corrected that. So we can have x squared plus 1 plus 4x squared all over 2 root x. Over 2 root x. These are like terms, add them, that will be 5x squared plus 1 all over 2 root x. Then these become our derivative or our gradient function of that curve we met. Thank you. Please remember to subscribe to my YouTube channel and hit the notification bell so that anytime I share a video, you'll be the first to receive. Thank you. Bye-bye.